Want to know how to protect your data in Python classes, just like locking your variables in a safe, right? That's exactly what encapsulation in Python OOP does, and I'll show you how it is in this video. Hello everyone, welcome back. So in this video, we will learn about encapsulation in Python object-oriented programming. By the end of this video, you will know how to restrict direct access to your data when working with classes and objects, why it's important, and how to implement it step by step. Alright, so let's get into it now. So encapsulation is one of the four main principles of OOP. I've created videos on the other three principles, which I will leave in the description below. It simply means hiding the internal details of a Python class and only exposing what is necessary. Think of it as placing your variables inside a safe and only opening it when with controlled method. That's exactly what encapsulation is going to do for you. Just as I said here, simply hiding the internal details of a class and only exposing what is necessary. So here is what you will do without encapsulation when you're working with class before. So let's say we have a class called bank account right here. So if I have a class called bank account right there, and I have a constructor as my init method right there, and this bank account is coming with a balance by default. And now I have a constructor that sets this balance, this instance, the instance of this class now set the balance to the balance that was given to it when it was created. So now if I want to create an account, I will just go like this, create an account. Okay, that should be, let's see here, right? Yeah. Create an account. I'll just call my back account class as a blueprint for creating the instance of an object 1000. Then I can just go ahead and print out accounts dot balance, and I can even go ahead and say, so if I should run this now, you can see I'm printing out the account dot balance right there. Anyone can access this and change this. Anyone can access this. What if we don't want anyone to access this? Another thing is anybody can change this. So let me illustrate that now by trying to change this to minus 4,500. Right. So now if you go ahead again and print out these, anyone can change this. And another thing is negative balance, which is another thing we don't want. So we want to be able to protect our data in this thing, which is, this negative balance now should be invalid and should be something that we should verify before creating this thing. So how do we make sure that we keep this safe? So in Python now we can use underscore or double underscore to indicate whether a variable is private. So I'm going to show how we can do that now. So we're going to create some method right here. So we are going to start with, okay, for now we want to make our balance variable private. So we use double underscore to make it private, which means it can only be modified by the class itself. If it's a single underscore, it is protected, can be modified by the class and any subclass itself. So let's just go ahead and say let's deposit right here now. So now we have a class for deposit, and I'm just going to go ahead and say save amount. So now when we deposit the money, what we want to do is to make sure that if this amount is greater than 0, we don't want to deposit any amount less than 0, which is going to give us subtraction, right? A negative balance. So once you just say save dot balance now is going to be modified plus equal amount. So that's the method now that is handling this data. So from outside, we want to restrict this access. So based on this double underscore, now if you try run this again, you will see that we will get an error. Anyone can access this. Back account has no attribute balance. What if I try to make it still this double underscore? Okay, let's say this because I changed the name, I'm not able to access it. Let's try that too. Back account has no attribute double underscore balance, which means this class itself is not even visible. outside the class. So alright, I'm creating some functions now, which I can refer to as access modifier. Then so I'll just go ahead and say def withdraw, and okay, just say amount again. So if I want to withdraw a particular balance now, alright, now first I want to check if 0 is less than amount. So if the amount less than equals to self dot balance. So I want to make sure that yes, the amount we have in the bank currently is enough for withdrawal. Right. So that's one thing that I want to make sure of, that what we have in the bank is enough for withdrawal. Then we just go ahead. After that, now we can now say self dot balance now minus equal amount. So this is how we withdraw. So there's something we call getters and setters method right there. So getters method are used to get this variable that we don't have access to. So we can use a variable to get it. And here I'll just go ahead and say get method. Get balance, I mean. So get balance now is getting this variable itself. Right there. And I can just go ahead and say return self dot balance itself. Then if I want to have a set method, which I don't think I should need, because the only thing I want to be able to do is to deposit and withdraw. That should automatically set my variable. But just for example's sake, but for a back account class, I don't need a setter method for the balance. But just to illustrate, I will do that right there. So you can just go ahead and say, okay, for this set balance now is, okay, I'm getting an amount also. The amount I want to set the balance to. And now if amount is greater than 0, because I don't want a negative account. I don't want to set it to a negative balance. I want to return. Right. So if this amount is greater than 0, I want to just, okay, yes, I want to save the self dot balance equals to amount. Then I just want to return the self dot balance. Alright. So now, if you now want to do this now, here now we try to access this get balance. So to fix that now, what we are going to do is just go ahead and try to use our get balance method. So now if we use our get balance method now, we'll see that we will be able to print this out accurately. So let me comment this out and see how this works itself. So here now we see that we can print our balance using this get balance method. This is a getter method and this is a setter method. So this is part of encapsulation, whereby we use these things to control the access modifier of the object itself. So now, if I want to withdraw now, I've printed my balance here. So let's say, okay, let me just have this. If I want to withdraw now, I can just go ahead and say access dot account dot now. So account dot, alright, what I want to do, okay, account dot deposit. Let me first deposit an amount right there. So if I deposit 3,000 and I try to print the balance again, if I try to print this balance again right here, then let us say, okay, let me just run this. So we can see my balance initially here is 1,000. Then after the deposit of 3,000, I'm printing it out. But let's say I'm depositing negative 3,000. Will I be able to do that? No, I'm not able to deposit that. That's because we have been able to control this, that we only want to modify the balance if it is greater than 0 itself. So we can see the usefulness of restricting our data access to outsiders right here now. Alright, so now let us say we want to test our withdrawal method. So I can just go ahead and say account.withdraw. So if I want to withdraw this now, just go ahead and say, okay, let's say I want to withdraw 500. So I can go ahead and say print again, get balance. And now we can see that yes, now after we have 3,500. right? That's because we've withdrawn that. And now for setting the balance, I can just go ahead and say account dot set balance, and I can decide to say after setting the 3,000, I can decide I want it to be 1,500 right there, which this should not be allowed in a normal bank account. But just let's just maybe it was a tracking app we want to use. So here now we can say that yes, we have been able to modify this bank account to this, and here now is working well. So you can, if you try doing this again, this won't work. It will not be allowed anymore. So Python has prevented us from touching this variable directly. That's how encapsulation works. And why should you try to use encapsulation? So the first thing is that it protects your data from accidental changes. It provides control over how your data is modified. Here now you can see some control over how it is modified, restricting negative balance, negative deposits right there. And it makes your code easier to maintain and more secure. So these are the three major things that this encapsulation do for us. So that will be all for today. So now let's have a quickly recap. So encapsulation means restricting access, direct access to variables. That's your behavior, your methods, or your attributes in your objects, in your class. But in Python now we use double underscores to make them private, or a single underscore to make them protected, which means a subclass of that class 2 can have access to the variable of the superclass itself. We interact with private data using methods like getBalance right there now. So you can see we interact with them, and if we want to set them, we use a setter method, setBalance. This helps protect our data and keep code balance. So you should know that now that is what happened. So now if these videos have helped you in any way, don't forget to like and subscribe, give it a thumbs up. Alright, for more videos like this, and we'll see you in the next video. I upload videos on Thursdays and Mondays. So see you in the next video. Bye bye.